Hi, everyone. Hope your day is going well. Today, you're going to be learning Target 2 from Unit 2, Solving Systems Algebraically. You're going to start with a warm up. It's at the top of your paper there. Then we'll go over the algebraic way to solve systems. Your closing activity will be a quizzes that will be linked on Google Classroom, and then your homework is a Math Excel. I will be checking to make sure that you've gotten both of these done before I return. So make sure these get accomplished by the time I return. Okay. So here's your warm up. So this is just solving systems on a graph, right? So you're going to hopefully do each of these in whichever way makes the most sense for you. So for instance, I would think everybody is going to graph 2x plus 6 using slope intercept form. So you're going to go up to 6. And then you have a slope of 2, so up 2 over 1, down 2 over 1, and you're going to try as best you can to make that line look accurate. So there's mine. It's pretty decent, I guess. And then I'm going to graph the other line, and if you prefer to rewrite it in slope-intercept form, you can. So I'm going to do that right now. So 2y equals, add the x over, divide by 2, y equals 1/2 x, and 6 divided by 2 is 3. So this is going to go up to 3 and then up 1 over 2. You can see I'm not going to cross going that way, so down 1 over 2. And it would appear to me that my intersection is at negative 2, 2. And remember, you can check that by substituting the values in to see if you get substitute the x in to see if you get that y. So if you put negative 2 in here, you get negative 4 plus 6, which is positive 2, which is this value right here. All right, now this one, I think it might be a little bit better to do with your intercepts as opposed to the slope intercept form. So remember what I mean by that is if you put 0 in for x into the first equation, cross off the x, you solve for y, and you get negative 2. And then if you put 0 in for y, so cover up the y, divide 2 by 3, you get x is 2/3. So this line is going to be graphed at 0, negative 2, and 2/3 0, which is kind of hard to get, but we'll get it there. And then I can draw that line. Let's see how I do with that. Move that a little bit. Okay, and then the second line, same thing. I'm going to put 0 in for x. That means I'm covering up the x part and just getting y is 12. And then I'm going to put 0 in for y, cover up the y, so I do 12 divided by 4 and get 3. Okay, so 0, 12 is kind of off the grid. 3, 0 is here. So I can try and graph this one. And see if I can find the intersection of these two. So it looks to me that that intersection is at 3, 4. So again, we need to check, right? So if x is 3, nope, that's a 2, isn't it? Let's try that again. So that's a 2, 2, 4. So let's try that. So if I put 2 in for x up here, 3 times 2 is 6, minus 4 is the y value does equal 2. So that does check out. That's kind of how I knew that that wasn't the right point when I put 3 in there. But that's a lot of work, right? It's trying to graph things to solve is not always the best method, especially if you don't have a grid. So that's why we need another method, and that's our two methods, solving by substitution and solving by elimination. So you should have learned how to do both of these already, right? You did this in Algebra 1. It's probably just been a little bit of a while. So when you're solving by substitution, you have to have something solved for one of the variables. So this first equation here is already solved for x, which means it's a really nice substitution problem. So what you do is you take what x is equal to, so 2y plus 4, and substitute it in for x in the bottom equation there. So you'll have 3 times 2y plus 4 plus 5y equals 1. So now you have 6y plus 12 plus 5y equals 1. I'm going to combine like terms here. So 6 plus 5 is 11y. I'm going to subtract 12 to the other side. So 1 minus 12 is negative 11. So I get y equals negative 11 divided by 11 is negative 1. So I have the y value. So now I take that y value and I substitute it up here and for y to find the x value. So I'll do x equals 2 times negative 1 plus 4. So 2 times negative 1 is negative 2. Negative 2 plus 4 is positive 2. So this intersection point is 2, negative 1. And you want to make sure you write it as a point. Okay, so that's substitution. And that, again, works really well if you have it already solved for one variable or if it's easy to solve for one variable. If it's not solved for one variable or not easy to do that, then you can switch over to the elimination method. So elimination is usually really good when you have x's and y's on one side and the constant on the other. So what you need to do is eliminate one of the variables by changing one of the equations around. So again, hopefully this sounds familiar as I go through it. So I can see there's a 2x here and a negative x here. Well, if this were a negative 2x, then I could add these two equations together and the x's would cancel and I'd be left with y's. But I can't just put a 2 there. I have to change the whole equation so it stays equivalent. So what I'm going to do is I'm going to multiply the bottom equation by 2 so that it becomes negative 2x. And then 6 times 2 is 12y. And then 8 times 2 is 16. Then I take the original equation that I had and I add it to this new equation that I just multiplied by 2. And again, the idea is that you will be able to get rid of one of the variables. And I know that many of you remember this because I heard you talking about this in class yesterday. So hopefully this is fairly familiar to everybody. So I add together, so negative 2x and positive 2x gone. They cancel out. 12 plus 5 is 17y. 16 plus 1 is 17. Now I can divide both sides by 17. I get 1. I take the 1 and I substitute it into one of the other two equations, and it doesn't matter which one. So let's say I'll put it in the top just because it's easier for me to put the arrow to. So I have 2x plus 5 times 1 equals 1. So 5 times 1 is 5, so I get 2x. I subtract the 5. 1 minus 5 is negative 4. Divide by 2. Negative 4 divided by 2 is negative 2. And then we want to remember to write it as an ordered pair. So I have negative 2 comma 1 is this intersection of those two lines. So it's the solution and it's the intersection of those two lines. Okay, so now there's a couple more here that we're going to talk about. So I'm going to do these probably a little bit faster than I did the other two, but always ask the sub to stop the video if you need more time. Okay, so when I look at these two, if I want to do this by substitution, and again, you get to kind of, on a test you get to choose, but on the quiz you actually have to do the one by each method so you can prove that you know how. But once you get to the test, you get to decide which method. So like if you look at this and think I would probably rather do elimination, later on you can. But right now we're going to go ahead and do this with substitution. And this is a good substitution problem because the y doesn't have any coefficients. So that makes that second equation really easy to solve for y. So I'm going to add the 3x to the other side. And then, like I said, y doesn't have a coefficient, which means I don't have to do any dividing, and it makes it a simpler equation to get one variable by itself. So I solved it for y. I'm going to take the 3x minus 9 and substitute it in for y into the other equation. So I have 5x plus 4 times 3x minus 9 equals 32. So now I have 5x, distribute the 4, 12x minus 36 equals 32. Combine like terms. 5 plus 12 is 17x. Add 36 to the other side. That is 68. Divide 68 divided by 17. I actually want my calculator for this one. Probably 4, right? Let's see. 17 times 4 is 68. Yes, so this is 4. Okay. Then I take the 4 and I substitute it back in to get y. And I can go back to any of these three equations that I want. So I actually think, get a different color in here, go. I actually think it's easier to take the 4 and put it in there because y is already by itself right here, but you can put it into any of the three equations. So I'm going to do y equals 3 times 4 minus 9. 12 minus 9 is 3. So my solution is 4, 3. Okay, this is the elimination one over here is probably the hardest of all the 4 problems, and that's because we have to actually multiply each equation by something to eliminate one of the variables. So I tend to choose the variables where they have opposite signs. So I see that I have a negative y here and a positive y here. So it's going to be easier for me to do some multiplication if these are already opposite signs. If I choose the x's, then I have to multiply one of them by something that's negative. But they don't cancel nicely, so I have to decide what to multiply by that will allow them to cancel. So you're kind of looking for like a greatest common factor. So I am going to multiply the first equation by 3, and I'm going to multiply the second equation by 4. And that'll give me 12y and negative 12y in those two equations. All right, so I distribute the first one. 3 times 3x is 9x. 3 times negative 4 is negative 12y, and 3 times 11 is 33. And then the second equation is 2 times 4 is 8x, 3 times 4 is 12y, 4 times negative 4 is negative 16. And then I add these two equations together. So the whole point is the y's are going to go away here, and I get 9 plus 8 is 17x. And 33 minus 16 is 17. I divide by 17. I get x is 1. I substitute the 1 into either one of the equations from above. So I'll pick that one. No, I don't like the negative there. I think I'm going to pick this one. So I'm going to do 2 times 1 plus 3y equals negative 4. 2 times 1 is 2. Subtract it to the other side. 4 minus 2 is negative 6. Negative 6 divided by 3 is negative 2. And my intersection is 1, negative 2. Okay, I am going to post this video on Google Classroom also. It'll be available after class. So if you want to go back and watch it again, if you are confused, it'll be available to you. And now what I want you to do is go to Google Classroom, and there will be a link for the quizzes activity that'll be like your closer to help you show that you understood what was going on.